What does it take to bring a car back from the dead when the manufacturer refuses to help? Mark set his sights on owning a Bugatti Veyron. 900,000 pounds later, he got one, split clean in half. Turned away by Bugatti, who refused to sell a single component. What followed was 6 months of reverse engineering, almost everything built by hand. Sensors, pumps, even a handmade clutch nobody could be sure would work. The car moved again for the first time in years. But one final test was still waiting. The obsession traces back to 2005, when Mark first saw a Bugatti Veyron in person. A machine that seemed to bend the rules of what a road car could physically do. He didn't have the money to buy one. What he had instead was a plan, and roughly 2 decades of patience. The climb started small. A transit van, a diesel Fiesta, then a Peugeot 106. By 23, side jobs like driving grooms to their own weddings had funded his first aspirational car, a Porsche 911 Targa. More Porsches followed, then a Lamborghini Gallardo, later swapped for a matte black Aventador he likened to something off a Batman film set. 2 decades of methodically working toward one goal, the Veyron's price climbing faster than his savings could close the gap. At its lowest, around 2012, a Veyron could be had for roughly £650,000, a price Mark later admitted he wished he'd acted on. But the Veyron market kept climbing toward £1 million, and in his view no modern car matched the engineering spectacle it represented. Then came the phone call that changed everything. A friend mentioned a Veyron far from perfect but far cheaper than anything else on the market. Walking into the workshop, nothing could have prepared Mark for its state. It was quite literally split in half, front and rear sections separated, mid-restoration and abandoned, the result of a gearbox problem no one had solved. The car carried its own pedigree, which made it more painful to see. It had been converted by Mansory, the German tuning house known for extreme, limited-run builds, with aluminum panels including a front bumper machined from a single block of metal and hand-polished to a mirror finish. Enthusiasts call it the shiny spoon look. It was a numbered example with only 8,000 miles on the clock. For £900,000, Mark bought it anyway. What he was buying wasn't a working car but a mechanical puzzle, because the one advantage every other broken-down car owner has, calling the manufacturer for parts, didn't exist here. Bugatti would not sell a single component at any price, so every fix had to come from independent specialists, cross-referenced parts, and reverse engineering. By the time restoration began, even the cheapest running Veyron in the country cost north of £2 million. Get it right, and Mark would own a numbered Mansory Veyron worth a fraction of that. Get it wrong, and £900,000 would sit in a garage as an ornament. With the car reassembled enough to run, the first problem was impossible to ignore. On cold starts, the engine sounded less like a hypercar and more, as Mark put it, like a tractor. This wasn't uncharted territory. Another Veyron owner, Matt, had documented an identical symptom, and the team confirmed the diagnosis by comparing it against a healthy Veyron at their specialist workshop, Falanga. The fix came from lateral thinking. Matt had discovered that the Veyron's mass airflow sensors, which tell the engine's computer how much air is moving through the intake, could be cross-referenced to a part from a different manufacturer. Falanga had test units on hand from tackling this before. Swapped in, the fix worked immediately, one problem solved without a single Bugatti part. The second issue was subtler but more important. The transmission relies on an accumulator pump to build the hydraulic pressure that pushes gear selectors into position. A weak pump can overheat, blow fuses, or fail to select gears at all. Benchmarked against a known good Veyron, the healthy pump built pressure in 24 seconds. Mark's took noticeably longer, and opened up, it was corroded internally. Bugatti's replacement was both expensive and discontinued, so Falanga sourced an aftermarket unit that reportedly outperformed the original, another fix outside Bugatti's supply chain. 2 mechanical fires were out. But the car's real make-or-break issue was still ahead. The Veyron's clutch was a different category of challenge, because the original friction material wasn't available at any price. The team's solution was almost unthinkable: build replacement friction plates from scratch, guessing at the material composition. The specialists brought in to evaluate the plates, Rob and Andrew, weren't random transmission experts. Decades earlier, at the engineering firm Ricardo, They had written the original software and mechanical characteristics for this exact gearbox. Their verdict, after rig testing, was cautiously optimistic. The kiss point, where the clutch begins transferring drive, measured slightly high but within limits. The bigger concern was something no rig could test: how the material would behave under real revs and torque on the road. The only way to know for certain was to drive it. While that uncertainty hung over the project, the bodywork told its own story. Years of neglect had left the aluminum panels oxidized and dull, with dents in every wheel arch. Bob, the man given the job, wasn't a traditional bodywork specialist. His background was building aluminum fuel tanks for motorbikes. His method looked destructive before it looked like a fix, heating each dent, hammering it from behind, welding, grinding, and polishing, repeated for 2 weeks until the mirror finish returned. The rear spoiler carried its own mystery, stuck permanently down and blocking several rear panels from being reinstalled. The culprit was a discontinued position sensor sold exclusively to Bugatti. The workaround was almost mischievous. Since the sensor tracked position via an external magnet, the team strapped an extra magnet onto the assembly to trick the computer into reading a safe position, then locked the spoiler fully raised and removed the magnet and sensor entirely. The system now permanently believed everything was normal. The project then shifted into the long, unglamorous work of reassembly. Small fasteners caused disproportionate headaches, a structural chassis nut, an engine mount bolt, a temporary hydraulic pipe repair, all parts Bugatti refused to supply, sourced instead through Falanger's network. Then came the moment the project had been building toward: the car moving under its own power, just a few feet forward and back. After everything it had been through, it was a genuine milestone. None of this would have been possible without the audience following along. Mark's presence online traces back to 2022, when a chance conversation on a BBC production set introduced him to content creation. 4 years later, his channel had grown to 1 million subscribers and, just as importantly, a network of specialists willing to dig into problems most workshops would turn away. But rolling a few feet across a workshop floor and surviving a real road test are very different things. The hand-built clutch was about to face the only test that mattered. Testing began cautiously, with the rear wing removed to protect the freshly repaired carbon fiber. Rob took the controls first, listening closely for engine load and any hint of shudder through the clutch. The results were encouraging. The engine held steady, the car crept forward smoothly, and none of the telltale vibration of a poorly matched clutch was present. Encouraged, the team moved to a proper road test. With the rear panels back on, Chris and Rob drove the car out of the yard while Mark, unable to fit in the two-seat cabin, watched from a distance. Within seconds, both men could tell something was wrong. The throttle felt slippery and disconnected, exactly the failure mode the specialists had warned about. Under real revs and load, the hand-built friction plates began slipping, unable to fully transfer power to the wheels, and an engine warning light appeared, cutting power as a protective measure. A second, unrelated fault struck almost simultaneously. The doors locked shut, forcing the team to bring out a step stool to get everyone out safely. The road test was aborted within minutes. Back at the workshop, the diagnosis was as straightforward as it was disappointing. The hand-guessed clutch material hadn't held up under genuine driving load, meaning the likely fix was pulling the gearbox out and splitting the car apart again, undoing much of 6 months of work. For a man who had spent 21 years wanting this exact car, watching that fear play out was clearly difficult to absorb. And yet, buried in the disappointment was the theme that had defined the whole restoration: a manufacturer unwilling to help, and a team of specialists solving an almost impossible problem with nothing but reverse engineering, borrowed expertise, and persistence. Every previous setback, the misfire, the failing pump, the locked spoiler, had eventually given way to a workaround. There was no reason to assume the clutch would be different, even if this fix would take longer and cost more than anyone had hoped. What began as a dream nearly 2 decades in the making became one of the most ambitious Bugatti restoration projects ever attempted. Split in half, rebuilt piece by piece, without a shred of factory support. Even with the road test ending in disappointment, the project proved that innovation often comes from those willing to solve problems everyone else considers impossible. The journey isn't over, and the biggest breakthrough may still lie ahead.